All right. They're both cross-country runners. Well, did Rachel run this year? Okay. Well, that's welcome to track. Okay, here we go. So please remember the type errors. I fixed the type errors on your paper, but they're not fixed up there. We clear? All right. We will get as much out of this as you let me teach out of this. So here we go. We started this yesterday. This is supposed to make things go faster so you don't have to type. Combustion analysis takes advantage of the fact that combustion always produces the same products. By accounting for the mass of CO2 and H2O produced, we can use stoichiometry to calculate the moles, please don't talk, of C and H in the original hydrocarbon. So you will notice right here, maybe I erased it. There we go. So in a combustion reaction, when they're the easy ones, I hate when it does that, but whatever. We have a C that has some number, an H that's some number, and then we're just burning it in the atmosphere. So the oxygen, we don't really account for it typically because it's free. It produces CO2 and H2O. And remember, this C has to come from that C, and the H has to be here accounted for as well. So we use this fact. The oxygen, once again, we don't have to worry about the oxygen when it's easy because we're just seeing the C's and the H's. When life gets hard, it's when it's C, H's, and O's plus O2, and you have CO2 plus H2O. We can't just say that this O and this O came from that one because they came from here too, which we don't account for, correct? So when these get a little harder, we have to find the amount of C, the amount of H, add those together, and then subtract this answer from the total, and that will leave me with just oxygen. Okay? And we're going to go over that step by step, but that's kind of where we're headed. So here we go. These are the easy ones. So when there's no oxygen, and look, the problem has to tell you there's oxygen. If it doesn't explicitly state oxygen is involved in the hydrocarbon, then you don't have to worry about it. You just do it the easy way. So use the given mass of CO2 to calculate the moles of carbon. Next, use the given mass of water to calculate the moles of hydrogen. Next, divide those two answers by the smallest of the two answers. Next, use these answers as the subscript to go with C and H in the empirical formula of the hydrocarbon. There's a little star that's super important. Next, if the molar mass is given in the problem, you must make sure your empirical formula adds to the molar mass. If it does not, you need to multiply each subscript by a single factor to get it to match the molar mass. We will work through every single part of these, but this little star, this sort of becomes really important for this worksheet. If dividing each answer by the smallest answer does not yield a whole number, which very often it will not, you need to multiply each answer by some number to get them to whole numbers. For example, if you do your math and you get 1.33, 3.33, and 1.33, you need to multiply all of them by 3, and now this would be a 4, this would be a 10, and this would be a 4. So they would all become whole numbers. This process, you kind of have to use some math sense to figure out how to make it a whole number. And we'll walk through that as we work through the examples. All right? Now, we'll come back later, but will you do number 1? Number 1 does not have oxygen, and it does not have, like the subscripts, when you do it, they are whole numbers, so it should go fairly quickly. If you got the answer that it's just C1 and H1, then you are correct, and you can ignore the next couple minutes of your life. You can move to number 2, which is a little bit harder. If you did not get C1, H1, then so we follow those steps. And we're going to convert to moles of C. All right, so I'm going to come over here. That was 0.845 grams of CO2. Then I'm going to put grams of CO2 on the bottom. The molar mass of CO2 is 12 plus 2 times 16. So that is 44 grams for every 1 mole of CO2. And then I know I have to bring down mole of CO2 right here. And then one part that really confuses kids sometimes is where I come. I have a mole of CO2 for every 1 mole of CO2. There's a, not written, but there's a 1 with that C. There is 1 mole of C, and there are 2 moles of O. So this ratio just comes from the chemical formula. So CO2 here, for every 1 mole of CO2, tell your lab partner how many C's are there? 1. So really, this first step, I'm taking the grams of CO2 and I'm dividing by 44. That's really all I'm doing. Okay, now, did anyone have this number? Actually, it's 0.0192, isn't it? Okay, so that's the answer for that one. The second part is similar. I just use water now. 0.173 grams of H2O for every 18 grams of H2O. And once again, the 18 came from 2 H's, which is a mass of 1, plus 1 oxygen, which is 16, and that's 18 grams per mole. So 1 mole H2O on top. I have to get rid of this, so it goes down. Mole H2O. Look at the screen. For every 1 mole H2O, how many H's are there? Tell your lab partner. There are 2 H's. So, if you look at this, by the way, like you can save some time if you feel like it. In this problem, you always are just dividing by 44, correct? In this part, you're always if you reduce 2 over 18. When you do the math here, you get 0.0192. Now, what do you do once you have them both in moles? What's the next step? Okay, you divide both answers by the smallest number. And then this one's 0.0192. This does not happen very often, so don't think, oh, they're the same number all the time. That's super rare. Like, in fact, it's probably only this problem in your whole life where they both have the same number. So when you divide, you get a 1, and here you get a 1. This is the subscript for H. This is the subscript for C. So it's C1H1 is your empirical formula. Now, that wasn't too bad. If this said that it actually had a mass of 72, no, 78. So if it said that the molecular mass was equal to 78 grams, which this substance really is, there's no such thing as just CH that's stable. You would do the following, and it's that one piece that said, hey, if the mass is given, you've got to find a way to fix it. So, what does C and H add to? It's 12 plus 1, right? So that's 13. So to figure out what you do, you take your given molar mass and you divide it by the mass of your empirical formula. And that equals what, Sam? 6. And what you do with this number is you multiply every subscript by that number. So you would end up with C6H6. That would be the real answer if it gave you the molecular mass. Okay, so that's number one. Number two is significantly more difficult because in number two, when you do the moles, it's not a whole number, so you have to do one other step. Let's take 4 or 5 minutes and try that one on your own. Ready? So if you have the correct answer, move to number 3. It's the same. Number 3 does not have oxygen either. The correct answer is C5H12. Okay. The way that we got this, and most of you as I walked around don't need the next 3 minutes, the next 4 minutes, so just move on to the next ones without me. It does not. Look real fast. Look at number 4 and number 5. Number 4, right here, it explicitly tells you it's C, H's, and O's. Number 5 also explicitly tells you there's an O. Number 3, it tells you how much oxygen is reacting in the plus O2, but it's still just a C and an H. This number is just giving you the mass of that, which honestly, and this is good practice, that's a useless number that we do not need at all for that problem. Okay, back to number 2 for those that needed it. One second. Oh, you little punk. Just give me some more room. Yeah, that will always be. All right, so number 2, we take our carbon, 38.196, that's grams of CO2, 4 grams of CO2, 1 mole CO2, 1 mole CO2 for every of C. I do the math, and I get, someone help me, it's 0.836, is that right? 868? 868 moles of C. Thank you, whoever that was. And then we have 18.752 grams of H2O. I down here have 18 grams of H2O for every 1 mole H2O. And if you're lost, rewind the video and watch it on how I got those. And then we have 1 mole H2O. For every 1 mole of H2O, there are 2 H's. I do this math and I get 2.0 something. Help me. 2.04? 2. Okay, thank you. Moles of H. Then I have them both in moles, so the next step is to divide both of them by the smaller number. That's the 868. That's a 1.868. And this is a 2.4, which is, that's when it gets frustrating. So what we have to do, we have to find a number that I can multiply this by to get a whole number. And if you will, if you can kind of think this through, you just look at this number and hopefully you know your multiplications and you think, what times 4 would give me an answer that ends with a 0? And go with the smallest. And the smallest one times 4 that gives me an answer that ends with a 0 is 5. So that means I multiply both of these by 5. And that's 12. And that now gives me the empirical ratio or empirical formula of C5H12. Okay. As I walked around, almost everybody was successful on that problem. Okay, number 3. It's very similar. Are the numbers bigger or smaller on this one? They're bigger. Okay. Give this a shot for a few minutes. Actually, could I say something real fast? It will save you time. If you understand what I say for the next 60 seconds, use it. If you don't use it. You can save a ton of time if you just boil these down to what they are. The first step, where we convert to moles of carbon, just divide the mass of CO2 by by the mass of CO2. Now, you did need a 1 and a 1 and a 1 scientifically, but math, just take your CO2 and divide it by 44, and that will give you your moles of C. In the water, it's the same idea. We just reduce to 1 over 9. All the science, the picket fence is important, but all the math, which is what we care about, is just 18 divided by 9. You can save yourself a ton of time. And when I do number 3, I will do that shortcut. Okay, go ahead and work. If you have C5H8, is that what we said? Then you are correct. I'm going to go through this. I'm going to use the shortcuts of just simplifying the picket fence. So I'm going to take 33.057 grams of CO2, and I'm going to divide it by 44, because mathematically that will tell me my moles of carbon. What was that answer? 0.7512. Thank you. Then I'm going to simplify this picket fence to just dividing it by 9. And science, I know it doesn't work, but math is all we care about in this problem. So I take my 10.816 grams of water, I divide by 9, and that gives me my moles of H. And what was that answer? 1.2? Okay, then the next step is divide both by the smallest number. And we get numbers. I can do the top one. That's a 1. Then this one turned out to be 1.2. No, what was it? Okay, so 1.6 is what I'm going to round that to. So how do you make a 6 equal a number that ends with a 0? Multiply it by 5, and that would be 30. Now we don't use the 30, that's just the logic. So we take this and multiply it by 5, and that gives me 5. I take 1.6, multiply it by 5, and that gives me 8. C5H8 are my subscripts, and I'm feeling okay. Okay. Now, everybody, number 4 is super different because it has what? It has oxygen. So I'm going to go back in my notes, and you'll notice steps when there is oxygen in the hydrocarbon, that is different. So, there's a lot of redundancy in these problems, and these can be simplified later also, but we won't today. Use the given mass of CO2 to find the grams of carbon. That is different. We were going to moles. We have to go to grams now. Water to find the grams of hydrogen. Then you have to add the grams of C and H together, and then subtract that number from the original mass given of the hydrocarbon. If it gives you the mass of oxygen, ignore it. They're just trying to make you get the answer wrong. You can only find the mass of oxygen by doing these first 3 steps. Once we have the first 3 steps, which is the grams of all of them, then we're off to the races. Convert all to moles. Divide by the smallest number. Use these as your subscripts unless they're not whole numbers. And if a molar mass is given, you have to account for that as well. It's very stepwise, but it's not the worst thing we've ever done. That is limiting reactants. Okay. For time purposes, I'm going to do it with you. Yeah, it says 176, which will screw with your mind. So I just changed it to 180 so you can sleep better. All right, so what I've done so far, and I'll need your help on the answers. I did the first step and the second step. I found the mass of carbon involved. Does anyone have that answer? Thank you. All right, and then I found the mass of hydrogen, which is point what? Okay, now these are grams, not moles, so do not divide these numbers right here by the lowest number. All right, so this is what we do next. It's the step that had a lot of words. We add these two numbers together, and we get 0.187 if I add these two together. And that's the C and the H. So I take the starting mass, 0.255, and I subtract the C and the H. And what do I get? Someone has it. Okay, I'm gonna try and move all this a little bit over. It won't let me grab it, so screw it. 0.0 what? 66. Okay. Grams of oxygen. Now, remember, when we do this combustion stuff, we do not have things diatomic. Okay. Now I have the grams of all of them. The next step is to divide these, to convert them to moles. To convert them to moles, you can do another picket fence or just save yourself time. To go straight from grams of one thing to moles of the same thing, you just divide by the molar mass. And I'm going to put the equal sign to the left. All right, this one is easy. That's 0.034. What's the top one? 0.2 what? Oh, wow. Okay, and this one down here was 0.0425 or something like that. No, 0.00. Okay, good enough. There's a number right here. What do you have, Sam, after the 4? Okay. All right, now these are moles. So the last step now is to divide all of these by the smallest number, which is this one. It's almost always oxygen, by the way. When I divide these numbers, this one is a 3, correct? This one is a what? A 9? An 8? Okay. And then this one is a 1. And those are my subscripts. How many C's? 3. How many H's? 8. How many O's? 1. C3H8O. Now, the final step of this particular problem, it does give you a molar mass right here. Well, it says 176, and that's a little off. So that kind of screwed people up. Go with 180 and you'll feel better about life. 180, these parts right here add to 60. Is that correct? Is that this problem? What I'm talking about is I have to find the mass of this substance. 3 times 12 plus 8 times 1 plus 16 equals 60. Now, 60, does 60 equal 180? No. So I have to divide 180 by 60, and what do I get? 3, which means all these numbers have to be tripled. So it's C, H, 24, O, 3. What's that? These are about as big as you should ever get. The next one, how many did anyone have C9H24O3? That's close. Did anyone have C3H8O? Okay, that's super good. And we still have Monday, so don't panic. Here are the answers to the next one. Now, if you work on these this weekend, there's samples in your or problems in your homework that are not required, but you can find the answers in the back of the book as well. There's multiple videos on the internet about how to do combustion analysis. There's a million websites. So on Monday, we are straight up going to review for our test. Now remember, the test has multiple choice that comes from where? From the reading of chapter 2 and chapter. All right, class is over now, but let's go ahead and work through this problem in case you needed extra help. So I'm just following those steps. If it had oxygen in it, which would be all of these. Okay, so you have these on that paper. It's when there is oxygen, and we'll just follow those through, hopefully from memory here. So the first thing I'm going to do is convert carbon dioxide to grams of carbon, and then water to grams of H, and we'll go ahead and go from there. So I have 0.257 grams of CO2. And I just set up a picket fence like we've been doing all day. 44 grams of CO2 for every 1 mole CO2. I need 1 mole of CO2 down here. For every 1 mole of CO2, there is 1 carbon, so it's 1 mole of carbon. Down here, I need mole carbon, and then I need grams carbon because the unit at the end is the unit at the end. And I put a 12 right there. When I do that, I get point. I hate when I do this. Hold on. Give myself a little bit of space. Might as well do it here too. I end up getting 0.07. I hope that's a 7. Hold on. So 0.0700-ish grams of carbon. Then I do the same thing for water. 0.035 grams of H2O. The molar mass is 18 grams of H2O for every 1 mole. H2O. 1 mole of H2O contains 2 hydrogen moles, whatever. And then 1 mole H is 1 gram of H. So I do that math, and it looks like 0.00388. Okay. Then I'm going to add these two numbers together because our C plus our H plus our O will equal my initial mass. Now, I know the initial mass, and I know C, and I know H, but I don't know O. So that's what we're going to solve for. So we'll just add C and H together, subtract from the initial mass, and we'll get our answer. So my C was 0.07, plus my H is 0.00388. I add that together, and I get 0.07397. Now I've rounded it a tiny bit, but that's what you end up with. And then my initial is 0.105. When I subtract these, I end up getting 0.03103. All right, that's correct. I'm looking at some handwriting that's I'm struggling with my own handwriting. So it's 0.03103, and that's grams of oxygen. So far I have converted to grams of carbon, grams of hydrogen. I have added and then subtracted from the initial to find grams of oxygen. The next step in this process is to now convert them back to moles. In order to convert to moles, you might want to add this to this. I should have probably typed this in the first place. It says convert the C and H and O grams to moles. You might want to add by dividing each by their whatever molar mass. So for carbon, you'll divide it by 12, oxygen 16, H by 1. Okay, that's what we're going to do now. All right, where am I? Here we go. So carbon, I'm going to divide by 12. Hydrogen, I'm going to divide by 1. And this oxygen grams, I'm going to divide by 16. All right, now I'm going to go lower on the page and write what these answers were. Now, these are in moles. So when I get these answers, I end up with 0.0058 moles of C. I end up with 0.00388 moles of H. Did I write that one right? Yep. All right, and then I end up with 0.001939 moles of O. So now they're in moles. I do the next step on the list, which is to divide each one by the smallest answer, which is oxygen's 0.001939, and that's a 1. I 0.001939, and this equals, that's a, whatever, 9. And that equals like 2.04, if I remember right. And that's close enough. If you're off just a few hundredths, it's not a big deal. So this is close enough to a whole number. And then when we divide this one, it's 3. So 0.001939, I get a 3. And once again, it's like 3.01 or something like that. So that's close enough to a whole number. Okay, so now I have my subscripts. I have 3 C's. I have 2 H's. And I have 1 oxygen. Okay, this is the empirical formula right here. The problem will also ask for the molecular formula, which we'll put right here. So the molecular formula is based on the molar mass, which is 108 grams per mole. This piece, if you add up 3 times 12 plus 2 times 1 plus 16, that equals 54. It should equal 108. So it doesn't take a genius to figure out if you double 54, it will equal 108. So we then put everything times 2, so it's C6H4O2. And that is our answer. Okay, hopefully that helped.